Hi, welcome to a video lesson about solving compound inequalities. This video will focus on AND type problems. All right, for the first few slides, just listen. Don't worry about taking any notes. Just see what's going on. It's going to kind of be a recap of what we've talked about. All right, this is a big idea. Inequalities and specifically AND type problems are a big part of a lot of mathematics you will do. So AND versus OR. AND means intersection. It means the intersection of two events. So in that diagram we have event A and event B. They intersect in the middle there. In the intersection both A and B are occurring. So it is an overlap. That's what AND means, an overlap. OR means union. It is a union of two events where one or both events exist. Union would be all of that. So when you shade there, over here, A is occurring, over here, B is occurring, over here, both are occurring. So as long as at least one of them is occurring, it is part of the union, and that's what OR means. This is an example we've looked at. So here we have x greater than 3 and x is greater than 2. Both of those are graphed on there. If we put an AND between those two inequalities, we now are looking for the intersection, or the overlap. So the overlap of these two number lines diagrams is this area here. This is the overlap. So the overlap begins at 3 and continues to infinity. So this is the AND region. If that was written as an OR statement, however, it would be anywhere where either one of them occurs. So here, one of them is occurring, here both are. So all of that is part of the union. At least one of them is happening. So that is the OR situation there. Okay, now please get your notebook ready. We're going to take some notes. I'm going to give you some specific examples of AND type problems. First one says, solve the inequalities 2x plus 5 is greater than 11 and 5x minus 7 is less than 18. For these, I'm going to move quickly. If you need to pause on each slide to get the notes down, please do so. So first inequality is solved. Looks like we subtract 5 from both sides. We divide by 2. And after dividing by 2, we get x is greater than 3. And, because this is an AND statement, we have the second inequality. So this one to solve, I'll add 7 first, and then divide by 5, and we get x is less than 5. Putting both of those on one number line, here's x is less than 5, here's x is greater than 3, but this is an AND problem. We're looking for the intersection, and the intersections where both occur, and both occur only in the middle here. So you need to write the solution. This is not your final solution. Sure, you can shade on here and all that, but to show the solution, you have to show it in its own number line. So here is the final solution. This overlap here between 3 and 5 is clearly shown on here. So this is the answer to this AND inequality. And written in set notation, x such that 3 is less than x and x is less than 5. Or you could say x is between 3 and 5. Written in interval notation is like this. Again, don't confuse this with a coordinate point. This is an interval notation. It means starting at 3, round bracket, not including 3. The comma means to 5. So from 3 to 5, not including on either end because of round brackets. And that same thing here, not including because of the open circle. Next example, solve the inequalities 3x minus 10 is greater than 2 minus x, and 4x minus 9 is greater than or equal to x over 2 plus 5. All right, another AND inequality. This one, you may think you know how to do it, but you might be wrong. You are thinking it says solve, but it says solve. So we're going to solve this problem. Let's do it. Here's the first inequality. Looks like we added 10 over here, moved that x over there. We combined like terms. Then we divided by 4, and we have x is greater than 3. And the second inequality. Here's our statement. Looks like multiplying by 2. Everything has been multiplied by 2 to get rid of this fraction here. Then we moved the x over, moved the 18 over. We combined like terms. Divided by 7, we have x is greater than or equal to 4. Put both of those in one number line. They have both been placed on here. This is an AND problem. It means we are looking for the intersection of these two events. The intersection is the overlap. These two overlap in the shaded region here. That is not a good enough answer. Let's make it on one number line. Here's a single number line showing that intersection. The intersection is from 4 to infinity. So here's your intersection from 4 onwards to infinity. And inclusive of 4 because they both exist at 4. Written in set notation, x such that x is greater than or equal to 4. Written in interval notation, from 4, inclusive with the square bracket, 2, comma, 2, infinity, round bracket. Infinity is not a number. We cannot include infinity. All right, here's another one. This one is slightly different than the last one. We have an inequality that's written in one large statement. There's no and here. However, when you see inequalities written in this form, it is implied that is an and situation. All right, and we can solve it by splitting it into two. So first we can look at this first half of it. All right, see how we've just taken that first bit? So there's one inequality statement, and we'll solve that on its own. So add 5, divide by 4, we have x is less than 5. Then we take the other half. So we're going to use that 15 twice. So and here's the other statement. So it's the 15 and onwards here. All right, so here it is. So that's how you take one inequality like that and split it into two. All right. So and then we subtract, so let's see, move the 7 over, move the 15 over, -7. Oh, here's something I saw a few students forgetting in the recent homework. We have a -7, -14. We're going to divide both sides by -7. When you are solving an inequality and you divide by a negative number or multiply by a negative number, you have to change the direction of the inequality. So notice how this is now facing this way. X is greater than or equal to that, and the answer is x is greater than or equal to 2. A final solution for that. So no, we're not even going to put the middle graph with both of them. Look, x has to be less than 5, x has to be greater than 2. So in other words, if you think about that, less than 5, greater than 2, it must be between 2 and 5. So x here you can see it's greater than or equal to 2, shaded circle, but it's less than 5, open circle. So here's the and region for that one. Written in set notation, x such that x is between 2 and 5, inclusive of 2. Written in interval notation, x goes from 2, comma, which means 2, 5, inclusive of 2, not inclusive of 5. Try one. All right, here's the problem. Pause the video, try it on your own. When you're ready, press play again, and the solution will be revealed. So try it, for real. Stop the video. Hey, have you stopped the video? Stop the video. Try it now. All right, here comes the solution. Did you get it? The final solution is x is between -2 and 2/3, inclusive of 2/3. All right, if you didn't get that answer, and here it is on the graph. If you didn't get that, look back on the work that you tried, look for your error. Hopefully that was no problem. Now we're going to move on to one word problem. Here is your inequality word problem. James scores 76 marks and 81 marks in 2 tests, respectively. That just means 2 separate tests. All right, find the the lowest mark he must obtain in the 3rd test. So now there's going to be another test. And it's saying, what is the lowest he can score in this 3rd test? If he needs an average score of at least 80. So if you look at the 76 and 81, the average of those two is below 80. I mean, if you're doing some mental math, you can see that. Those two average will be below 80. But his goal is to get an average of 80, or at least 80. So that means in the next test, he's going to have to score above 81 in order to bring that average up. But how do you figure this out? So let's check. So solution. Let x be the marks obtained on the 3rd test. So to find an average, you may remember, you just add the things you need to find the average of and divide by how many items there are. So his 1st test score plus his 2nd test score plus this unknown score on the upcoming test, and we divide by 3, because to find the average of the 3 tests, we're going to divide by 3. And that average, it says, must be at least 80. So his average, this number here, must be greater than or equal to 80, because that's saying at the lowest it will be 80, but he wants it to be higher. So now let's see what happened. Added those 2 numbers. Oh, everything was multiplied by 3 to get rid of this 3. So 3 times on this side gets rid of that 3. 3 times on this side brings it up to 240. You have this. looks like we subtracted the 7681, and now we have this number. X is greater than or equal to 83. So just as I noticed in the beginning, he has to score higher than he has on his previous two tests in order to bring the average up. And what is that? 83. So James must obtain at least 83 marks on that third test to get his average of 80. All right, that's a kind of a typical kind of inequalities word problem. Here's another one for you to try. All right, here's the problem. I will read it, pause the video, and try it. Don't cheat. Don't look for the answer. The answer will come in a moment. But you know what? Try it on your own first. You need to do this stuff, all right? Here's the length of a rectangle, and it is given as 4 meters. 4 meters longer than its breadth. So the width. Breadth means width, right? So rectangle has is wide, but we don't know the number. We don't know how wide it is. But we do know that the length is 4 meters longer than how it is wide. And its perimeter must be at least 120 meters. All right, think about that. A, if the breadth or the width of the rectangle is x meters, write down, but do not simplify, an inequality in x. So in other words, write an inequality that has that variable in it. And then B, solve the inequality and find the smallest possible area for the rectangle. So, all right, good word problem, good use of inequalities, good math here. Give it a try. Pause the video. All right, if you're still playing the video, I'm about to show the solution, so pause it if you're trying. And here comes the solution. So we're going to say the width is x, the length is then x plus 4, because it said the rectangle is 4 meters longer than it is wide. So there's the length. That means the entire perimeter is 2 times that. As you know, a perimeter of a rectangle is, imagine there being a rectangle here. I don't have one, but imagine it being long and then one side. So you add the 2 sides and you double it because the other 2 sides are the same length as well. So there's your perimeter, and it must be greater than 120. So there is the inequality unsolved, as it said to do in part A. Part B, solve it. So multiply, combine, solve, solve, solve. X must be greater than or equal to 28. So in order to meet the condition of having a perimeter greater than 120, x must be greater than 28. All right, anything lower than 28, the perimeter won't be bigger than 120. So now it says, the question said, what is the smallest possible area? So the smallest x can be is 28. So then the smallest area would become from using the smallest value of x. So the perimeter, or the area, is length times width, right? So here's the length, the 28, or the width, and the length, which is 4 longer than that. You multiply those two numbers and you get the area. And this is the smallest area because we used that smallest possible value for x. Good problem. Make sure you understand it. This is the kind of word problem that should not be too difficult for you at this time. All right, see you next week.